Let's go over a couple of practice problems for quiz 2. In question 1, we'd like to write the following Hindu Arabic numerals as Roman numerals, using these symbols and their values as a guide. Starting with 658, for the 600, we can use the letter D to represent 500 and follow that with a C to get 600. So to start this, we can say this is D followed by C. This takes care of the 600 part. Now we have this 5, which is 50, and we can use the symbol L for 50. And finally, for this 8, we can express this as V, which is 5, followed by 3 I's, which are each 1. So this is V, I, I. So here it is, the Roman numeral to represent this Hindu Arabic numeral. Notice that we did not break the convention of writing any symbol more than 3 times in a row. Let's repeat this process, but with 3,494. So first, for the 3,000, M represents 1,000, and we want 3 of them, so we can put 3 of those in a row. So M, M, M. This is 3,000. Now for 400, what we're going to do is use a subtractive approach. You could write C, 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 but that would be breaking the convention of writing a symbol more than 3 times in a row. Instead, D is 500. If you put a C before it, you're saying subtract 100 from 500. So for the 400, that is C followed by D. This is 2 symbols to represent the 400. Same idea for 9, this 9 here, which represents 90. To use 2 symbols to represent 90, we can say that C is 100, and if you put 10 before it, you're subtracting 10 from 100, which is 90. So this is X followed by C. So these 2 symbols represent the 90. Lastly, for 4, again, you only want to use 2 symbols for this digit. 5 is V. If you put an I before it, you're subtracting 1 from 5, which is 4. And so that is going to be IV. And that's it. This is how you express 3,494 using Roman numerals or Roman notation. In question 2, we're going to use divisibility tests to see if these numbers divide this number over here. So we must use those tests in explaining our answers. Starting with 2, does 2 divide this number? And the answer for this one is no. And this is because 1402, 110045 ends in an odd number. Because it doesn't end in an even number means 2 cannot divide the entire number itself. Moving on to 3, does 3 divide this number here? The test that we're going to use is we look at the sum of the digits. If 3 divides the sum of the digits, then it divides the entire number itself. So I'm going to look at, let's see, that's 1 plus 4. I'll skip over the zeros. I don't have to write those. I'll just put 2. I'll add the 2 1s. I'll skip over the 2 zeros and put a 4 and a 5. This is the sum of the digits in this number. If you look at this sum, this adds to 18. And 3 divides 18. Since 3 divides the sum of the digits, it divides the number itself. So for this one, the answer is yes. As 3 divides 18, we have that 3 also divides the entire number, which was 1, 402, 110, 045. Moving on to 4. Does 4 divide this entire number? You only have to check the last 2 digits. So I know that 4 does not divide 45. For this reason, because 4 does not divide the last 2 digits, it does not divide the entire number. So I'll say, so 4 does not divide the entire number itself, which I'll write it down. And so the answer to this one is no, 4 does not divide the number. What about 5? Does 5 divide this number? And the answer is yes. I'm just going to say that the number ends in 5, and therefore 5 must divide this entire number. The entire rule was if the number ends in a 0 or a 5, then 5 must go into it. So the answer to this one is yes. And this is because 1402, 110, 045 ends in a 5. Therefore, 5 must go into it. We are at the last digit, which is 6. Does 6 divide this number? The rule for 6 is if both 2 and 3 divide this number, then 6 must divide this number. If at least one of them does not divide this number, then 6 can't divide this number. And so for this last one here, the answer is no. And the reason is 2 does not divide the number. And so 6 cannot divide the number either. The rule is both 2 and 3 must divide this for 6 to divide it. In question 3, we're going to use divisibility rules to explain if 9 divides this number, and also if 8 divides this number. We have to reference the rules to check this. The rule for 9 is similar to the rule for 3. Essentially, you add up the digits in the number. If 9 divides that number, then it must divide this whole thing itself. So for this problem, we're going to look at the sum of the digits. I'm only going to add the non-zero digits. So the sum of these here. So this is 9 plus 9 plus 9, and that's 27. So here, 9 divides 27. Therefore, this is a true statement, meaning 9 divides this number because it divides the sum of the digits. Now, the rule for 8 is you only have to check the last 3 digits. So that is these digits here. If 8 divides 136, then it also divides this entire number. So let's actually do the math out for this. Does 8 go into 136? All right, so 8 goes into 13 once, goes in 8 times, subtract that, you get 5. And if you bring down the 6, 8 goes into 56 17 times. This leaves us with a remainder of 0. And what that means is 8 divides 136. As this is true, this is also a true statement. So the rule for 9 is similar to the one for 3. You add the digits, and if 9 can divide that number, it divides the number itself. If you check the last 3 digits for dividing 8, if 8 divides that number, it divides the entire number itself. In question 4, we're going to evaluate, or really just simplify these expressions here. Starting with part A, which is the absolute value of 500. If you take the absolute value of a positive number, it is simply that positive number. I think the only other thing to note is if the thing inside the absolute value is negative, it makes your answer positive, and the absolute value of 0 is 0. Those are the only cases to consider. For part B, this is negative 75 minus negative 100. For this question, if you see a minus, if you're subtracting a negative, that is the same thing as addition. So this is negative 75 plus 100. And it might be nice to order this as put the positive number first, and really you can think of this as 100 minus 75. If you take this difference, the difference is 25, and that's the answer for part B. In part C, we're dividing two numbers, 888 divided by negative 8. I think the thing to note for this problem is if you're dividing two numbers and one of those numbers is negative, that means your entire answer is going to be negative. So really you can think of the problem as this. Put this negative in front of the fraction. The reason for this is you can focus on simplifying this, and we're just noting that the answer is a negative number. How many times does 8 go into 888? Well, it goes in 111 times, so therefore this is the answer to simplifying this fraction. Parts D and E are very similar, and this is really an order of operations question. So when I look at this expression, this says we have negative being multiplied by 10, which is raised to the power of 2. To simplify this, we are first going to deal with the exponent and then multiply by the negative number afterwards. So really step 1 is, what is 10 squared? 10 squared is equal to 100. And then we're putting that negative in front of it. In fact, there's nothing left to simplify, and so our answer is negative 100. If you compare it to this one down here, this is squaring, but you're squaring both the 10 and the negative. In fact, using the definition of what it means to square something, basically you just copy down this thing twice. So this is negative 10 multiplied to negative 10. This is what it means to square negative 10. You put it next to itself 2 times in a row. Because we have a negative times a negative, that means the answer is going to be positive. It's going to be positive 10 times 10. 10 times 10 is 100. I'm just going to write this as 100 for my final answer. You don't have to put the positive in front of it. So these are the answers for parts A through E.